So our learning target for today will be able to use vertex form of a quadratic to determine the characteristics of its graph. Now, quadratics we can see in standard form, and that's what we've been most used to. Just that standard form where it's x squared plus bx plus c, but there's another way to write it, which is vertex form, and vertex form writes it like this. Now let's know that vertex is just another word for the turning point. And we've talked about that a little bit lately, where it's the part of the U shape that kind of changes it from one direction to another. So we are going to talk about the advantages of vertex form. One thing that we're not going to do this year is actually show you the process of putting it into vertex form. You are also welcome. We will not have to worry about completing the square. So if you're an algebra student that has heard that term before and remembers the difficulty of that, I've decided in a virtual world we're going to leave that part out. So it is something though, if you wanted me to kind of talk to you about it outside of school or outside of class, that is, on an office hour kind of day, we could go over that, but not all that important to what we're trying to get through this year. So let's get us started with the first example. Here we have a quadratic, the most basic of them all, just simply x squared, okay? So if we look at a quadratic that is an x squared, let's go ahead and put it in our calculator. So calculator's up, and press y equals, clear out whatever you might have currently, use the variable key, and then square it, okay? I'll let everybody get a chance. Is the table, in the sense that this is x squared. So second graph, and I am way out of whack here, so let me get myself to 0. So I'm going to start my table at 0. And if you didn't follow what I just did, that's okay. Scroll up or down until you see the table at 0. And let's take a look at some of these. We've got -3 as the x value. -3 times -3 is 9, right? And -2 times -2 is 4. And -1 times -1 is 1, and then 0 times 0 is 0. 1 times 1 is 1, 2 times 2 is 4, and 3 times 3 is 9. So we get that U shape, we get that repetitiveness, and we're just squaring the x value, okay? So please understand where these numbers are coming from. Now, that has already been graphed for us, okay? 1 over 1 up. 1 times 1 is 1, but 2 times 2 is 4. And over here, -1 times -1 is +1, and -2 times -2 is +4. So that's why we see those values. Now, we want to take a look at the next function, the g of x, which is said to be x minus 2 squared, then -4. And we want to put this in our calculator to kind of generate those numbers, those table of values. So let's do that. Back to y equals, and then you want to type in everything as you see it, parentheses included. So we're going to start parenthesis, variable key. Remember, when I press it, it turns red, so that's how you could try to follow along with me. -2 parenthesis. Now we do want to square this, so x to the second power, we'll square it. And then subtract 4. Just going to take a quick. So there's my table, and I've got obviously both values. I've got 2 different functions in here, and I'm just going to scroll down to see if I can find where it kind of, yes, does that rainbow effect, where I see in the second column 5 and 5, 0 and 0, -3 and -3, and then the -4. All right, so there's where it kind of has that rainbow effect. So why don't we go ahead and get that table down. And then from my table, the next point is 0, 0. And then it is 1 down 3. And then 2 down 4. There's the turning point. And then it's going to be 4, 3, -4, 4, 0, a 0 value, and 5 and 5. Okay? So I go ahead and I just draw my U shape. There we go. Now let's think about this. Let's think about the original shape that we had. Let me use a color for this one. All right. Now, what would it take if we were trying to shift the graph f of x to get the g of x? So if I took this one right here and I just moved it to get to here, well, watch this. if I just pay attention to that turning point, this one right here, I can see that it's going to take it 1, 2 to the right and down 1, 2, 3, 4. So 2 to the right, down 4, and look at that, it's the exact same shape. All right, 2, comma, -4. Now, where can I see that turning point in the equation? Well, let's see if I can get my highlighter tool out here and see that it's got a 2 and a -4. So that's pretty cool that it's actually got it right in the vertex or turning point form, right? So let's go ahead and write that. G of x is x minus 2 squared minus 4, where here is the y value, clear as day, and this is the x value, but it is the opposite. So that's one thing you're going to have to think about, is that it's always the opposite x value, where this was -2 inside, and it's really a +2 here. Okay? I think we're ready just to do an easy one here, okay? So let's just take a look at a parabola that we want to try to come up with its equation. And you're like, are you kidding me? We can come up with the whole equation just by looking at the graph? Yes. So it's all about that U shape. So it's 1, 2, 3 to the right, down 1, 2, 3, 4. So the TP, also known as the vertex, is 3 to the right, +3, and then -4. Now, what did we say? We said that this is the y value, and this is the opposite x value. So let's take a look at the equations and see which one's going to work. It needs to be down 4. So this one works, not going to work, not going to work. So 3 and 4 are out of there because of that +4. Now, the turning point has a +3, but when it's in the equation, it's the opposite, so it needs to be a -3, and that's why this is choice number 1. Let's kind of simplify this even more and see if we can come up with the turning point, which is also the vertex. Stinks that I got to use the same or 2 different words for the same thing, but that's the situation that we're in for the following equations, all right? So we just want the TP, turning point, all right? So it's an x and a y value. Well, if this is a -8, +5, 5 stays the same. The x value, the one that's next to the x, is the opposite, so +8. And that's it. We just use these 2 numbers, and they're in the same order, which is awesome. Next up, we want the turning point, the vertex for this equation. Well, pay no attention to the 5 right now. We'll talk about that in just a little bit, but the turning point comes from the other part of this. So if that's a +1, we got to write -1, but the -4, we use that sign in front. Okay? I'm going to poll the audience real quick to make sure you're still with me. Would like to know the turning point of this next equation. Remember, as of right now, we don't know what this number in front of the parentheses means. We will in a moment. But the turning point is always the opposite x value. So +3, same y value, 10. That's where the parabola will make its change and give us that U shape. All right. I did add a little bit to the notes because I just wanted to make sure that we were clear on this. So you can put this probably at the bottom of the page. There should be a little bit of room, and if not, maybe think about trying to find some room on another sheet of paper. Back your practice, I think there's a blank page, but just real quick, I want to write an equation in vertex form given a turning point. Well, if you look at the top of the notes, I do say that the vertex form, and that's a bad color to use right now, so let's use something brighter. There we go. Is y equals, and we can consider this, I'm not going to put the other number out there, but x minus h, oh boy, parentheses squared, and then plus k. So we're just trying to fill in something for the h and for the k. So I know that there's an x and y, and it's very kind of easy to think about -5 for x and 8 for y, but no, not here. We're going to do y equals parenthesis x. So that part stays. But if it's a -5, it's got to go in as +5, and then we square all that. And if it's +8, then we add 8. We do keep that the same. So there you have it. This would be your h and your k value because they are turning points. Okay? Just to be clear, let's try that one more time for 4 and -7. So thinking about that equation that we talked about, y equals parenthesis x, that's going to stay the same every time. The 4 is positive in the parentheses to start, so then it's -4 squared, but the 7 is negative, and that does stay the same. So here we have a single point, and we wrote, so we have the graph f of x equaling x squared. So there's the one where, again, if you take the x value and you square it, 1 times 1 is 1. 2 times 2 is 4. -1 times -1 is +1. -2 times -2 is +4. So that's how we get that. So I'm going to go ahead and draw this in and do a quick little sketch. Okay? Now, we want to go ahead and graph g of x, which is half of what we saw, and then we want to go ahead and do h of x, which is twice x squared. Now we're going to use our calculator to kind of get us going here. So calculator's out, y equals, and let's go back and put in x squared as the first one. I am going to get rid of my other one here, and I need to put in half of x squared. Easiest way to do that is to do x squared and divide it by 2. So there's half of x squared, and then the other one is 2x squared. So get that in your... So press graph, and we will see the original x squared, and then we got one that's a little bit wider than x squared, and one that's inside of it. So we have one that's wider and one that's more narrow. So let's get a little bit deeper into this by pressing second and graph to see the table for these. Okay? So the first one you're going to see is the combination of x squared and half of that. And notice that the y values are half. So half, 0, half, 2, 4.5. So it's half of what you see in the other column. Half of 16, 8. Half of 25, 12.5. So let's go ahead and put that one down. So if I go, and let me get a different color here. If I go 2 to the right, then half of 2 is only 1. If I go 4 to the right, then half of 4 is only 2. So the y value is literally cut in half. Same with the other direction. If I go 2 this way, it's only going to give me 1. If I go 4 this way, it's only going to give me 2. So this is going to be a situation where we do a much wider parabola. And so that is the g of x equaling 1/2 x squared. So I got my little magic eraser here, and underneath this you will see that g of x is wider than f of x because the y values are half the size. Go ahead and get that down. Now let's take a look at the calculator for the twice x squared. So twice x squared is over here in the y3 column. And so we can see that these are actually twice the size of the x squared. And I'm actually going to do something to help you see that even better. I'm going to clear this one out. And now we can see 1 becomes 2, 4 becomes 8, 9 becomes 18. They are twice the size when you multiply it by 2. Now how does that affect it on the graph? Well, if I go over 1, now I'm going to go up 2. It's going to be twice the size. And if I go over 2, well, now it's actually going to be up even more than that. It's going to be up 8. Where'd my little point go here? Yeah. So 1, 2, 4. Is that even where I want that? 2, 2. Oh, sorry, 6 up here. And then the same on the other side. So it's going to be 1, 2, and then even here. So it's going to be inside of the original because it's even taller. It's more narrow. The outputs are even bigger. So let's take a look at that.